What is ground survey? Ground survey refers to the process of collecting and analyzing data about the Earth's surface and subsurface using various techniques and instruments. Ground surveys can provide information about the physical and chemical properties of the Earth, as well as information about the geology, topography, and other features of the landscape. Ground surveys are often conducted in the context of geological exploration, environmental monitoring, or civil engineering projects. In geological exploration, ground surveys are used to locate and map mineral deposits, identify potential hazards such as landslides or sinkholes, and determine the characteristics of subsurface rocks and minerals. There are many different techniques that can be used in ground surveys, including geodetic surveys, which use high-precision instruments to measure distances and angles between points on the Earth's surface. Topographic surveys, which use aerial or ground-based methods to map the topography of the Earth's surface. Geophysical surveys, which use various techniques to measure the physical properties of the subsurface, such as the magnetic or electrical properties of rocks and minerals. Remote sensing, which involves using satellites or other instruments to collect data about the Earth's surface from a distance. Ground survey data can be used to create detailed maps and models of the Earth's surface and subsurface, which can be used to guide resource exploration, land use planning, and other activities. Ground survey data is also often used to monitor changes in the Earth's surface over time, such as the effects of erosion, subsidence, or sea level rise. Why is ground survey done? Ground survey is done for a variety of reasons, depending on the specific goals of the survey. Some common reasons for conducting ground surveys include geological exploration. Ground surveys are often used to locate and map mineral deposits and other geological resources. By collecting data about the physical and chemical properties of rocks and minerals, ground surveys can help geologists determine the location, size, and quality of potential mineral deposits. Environmental monitoring. Ground surveys can be used to monitor changes in the environment over time, such as changes in land use, erosion, or the effects of natural disasters such as earthquakes or floods. This information can be used to guide land use planning and environmental management decisions. Civil engineering. Ground surveys are often used in the design and construction of infrastructure projects such as highways, bridges, and buildings. By collecting data about the topography, geology, and other characteristics of a site, engineers can design structures that are safe and stable. Archaeology. Ground surveys can be used to locate and map archaeological sites and other cultural resources. By collecting data about the physical characteristics of the landscape, archaeologists can determine where to excavate and how to interpret the results of their excavations. Overall, ground surveys are an important tool for understanding the Earth's surface and subsurface. By collecting and analyzing data about the physical and chemical properties of the Earth, ground surveys can help guide resource exploration, environmental management, and other activities. How is a ground survey done? Ground surveys are conducted using a variety of techniques and instruments, depending on the specific goals of the survey. Here are some common steps in conducting a ground survey. Planning. The first step in conducting a ground survey is to develop a plan that outlines the goals of the survey, the methods to be used, and the resources required. This may involve consulting maps, satellite imagery, or other sources of data to identify the features of interest and determine the best approach to collecting data. Fieldwork. Once a plan has been developed, the survey team will typically conduct fieldwork to collect data. This may involve using a variety of instruments, such as GPS receivers, total stations, or ground-penetrating radar, to measure distances, angles, and other parameters. In some cases, the survey team may also collect samples of soil, rock, or other materials for laboratory analysis. Data processing and analysis. After the fieldwork is complete, the data is processed and analyzed to create maps, models, or other visualizations of the Earth's surface and subsurface. This may involve using specialized software to integrate data from multiple sources and create 3D models of the terrain or subsurface features. Reporting and interpretation. The final step in conducting a ground survey is to interpret the data and communicate the results to stakeholders. This may involve creating reports, maps, or other visualizations that explain the findings of the survey and provide recommendations for further action. The specific techniques and instruments used in a ground survey will depend on the goals of the survey and the characteristics of the site being surveyed. Some surveys may involve collecting data over a large area, while others may focus on a specific feature such as a mineral deposit or archaeological site. Regardless of the specifics, a well-executed ground survey can provide valuable insights into the Earth's surface and subsurface, helping guide resource exploration, environmental management, and other activities. Please don't forget to subscribe to my channel and turn on notifications.